Hello guys, look at what we are doing for today. This is a refraction practical. I know a lot of you don't want to see this practical. A lot of you don't like this practical. We know, as experienced tutors, we know you don't like it. You don't just want to see it. After seeing a lot of writings on the board, and they're now telling you to perform this. And the fear comes when you see these optical pins, because you get that now. They tell you to close your one eye. Of course, I've been told that before, but today I'm going to show you how you're not using this for this practical, you're not using this for this practical. What you need for this practical is this. You're shocked, yes. What you need for all this writing you are seeing on the board, for all what they ask you to perform, is just these two very particular apparatus. Do you need this? No. Do you need this? No. Let's get started. Let me show you. You're welcome to today's practical. Very important. I want to show you how refraction practical is being done. I want you guys to pay maximum attention. This is the question. This is a question. This is the diagram, and you have all these questions for this very particular practical. Very important. We already understand that in physics, optics is one of the practical you cannot escape. If you're writing JAM, you're writing NECO, you're writing WAEC, it's an important aspect of physics that you need to understand. And I understand a lot of students used to find this difficult, but let's come closer and see what the question is. This is the diagram, this is the question, and from there you have them doing all this. Let me show you how to do this. Let me show you how to do this. We have our drawing paper already. They would have given you in your various center, hopefully, our optical pins, our thumb pins, everything, your rectangular glass prism, and this, you have it here. Please help me with my marker, you have it there. Placing like this. You place like this, right? You place like this, you begin to draw, and you begin to look for your pin. I think a lot of students will know what to do this practical. You know why? Because this is the place you see students telling you that they have eye problem. All in the name of them finding it difficult to locate all these things. Of course, I have done this on this channel actually. I have done this very practical where we actually use our optical pins to get all these things. I did it in the practical. But the truth is this. What I want to show you today is how to do this without all this rectangular. I don't need this. I don't need this. What I just need is this. With this and this, we're going to carry out this practical and we're going to get our readings, and it will be very correct. So I want you to pay maximum attention so that a lot of people have seen, even in WAEC, you see a lot of students will not want to do refraction. They will not. Especially the fear of rectangular glass prism and triangular glass prism is the beginning of wisdom for students. They will not want to do it, but actually it's the easiest. And I just want us to understand principle. One thing about physics is that for every physics practical, it comes from a physics principle. We should know that. For every physics practical, it comes from a physics principle. So when you understand the principle now, it is what you now use, that's what you will apply to now doing the practical. So, and it will be very correct. So for any physics practical you have seen, it came from a particular principle, and that's what I want to show. So I want us to pay maximum attention. Let's come closer. Let's look at this. This is the rectangular glass prism. Look at what I want to do now. This is the rectangular glass prism, right? From this rectangular glass prism, they gave us our eye already, right? Which means if this is our eye, from my knowledge of rectangular glass prism, it means that this will be my eye. They didn't give us our eye. They didn't give us our eye. They didn't even talk about the eye. If you read what they want us to get, they are more interested in our NX. They are more interested in this. That's what they are interested in. Because if you make a position N very close to A, then replace the triangular prism. If you read through, draw a line to join the points P3 and P4, producing the line to meet BC at S. Join NX. So join N and X. Do you see? So they are more interested in the length of this, because this is N and this is X. Let's see further. Measure and record the distance NX as L. So this N and X, the distance between here and here, they said we should record it as L. Then our RX, where's our RX? The distance between this place and this place, we should record it as RQ. So they didn't even talk about refraction. And even if they ask us to still get refraction, I was thinking, in fact, that's the easiest, that's the principle. we are using. Okay, so how do we get this without even touching all this practical? That's what I'm interested in. So that when you understand all this, you know how to call it out the practical. So if this is I, don't forget, this is our refraction. And don't forget, this one is very important, our emergence. This is our emergence rate, right? So, but we are not doing that. I just want to explain in simple terms. What do we do? I understand a principle called Snell's law in physics. And that's the principle we want to use to do all this. Snell's law. And what is Snell's law? N is equal to sine I over sine R. The ratio of the angle of incidence to the ratio of the angle of refraction is constant for any given 2p of media. That's what Snell's law is saying. So it is Snell's law. Now look at this trick here. Look at the trick. If I can get my R here, this will be correct automatically. Because this line came from this angle R. So, and I know that the refractive index of glass is around 1.33 to 1.55. But for me, I love using 1.50. I love using the refractive index of glass to be 1.50. So my N is from 1.33 to 1.55. That's the refractive index of this glass. So I want to pick 1.50 now. Don't forget they are giving us our sine I, because they said draw a line Tn to make an angle I, which is 60 degrees. So I know my 60 degrees. So I want to get my angle of refraction for each of these angles, for 60, for 50, for 40, for 30, and for 20. So this is what we do. Let's bring it closer so that we can see. So I'll say, using this law, N is equal to sine I over sine R for the first one. What is my N? Don't forget, I said I'm using my N now to be 1.50 all through. I'm using N. So my N will be 1.50 equals to my sine. What is my I for this place? My I here is what? Is 60 degrees. 60 over sine R. Let's just get this so we know what to do. So from here, let's do it gradually so that everybody will be carried along. So from here, I'm looking for R, so I can cross multiply, right? So if I cross multiply, I will have sine R times 1.50 is equal to sine 60. Is that not? So from there, we divide both sides by what? Because I'm looking for the R. So we can divide both sides by 1.50. 1.50. Right. So from there, let's do sine 60. What is sine 60? Sine 60, that's 0.866, right? 60 divide 1.50. That's giving me 0.577. Let's take to 3 decimal places. So I have my sine R to be equal to 0.577, right? 577, and I'm looking for my R. So what do I do? I'll just do shift sine 0.577. So second function, that's shift sine 0.577. So my R here is around 35 point. Let me do to 1 decimal place. That's 35.2 degrees. Please note all this. So which means, what is the function I'm using now? I'll be doing sine of the angle given over 1.50. Anything I get from there, I'll do the second function to get my R. So I've done for, this one is for when I equals to 60 degrees. Right? So when I now is 50 degrees, very fast now, what do I do? It will be sine 50 now. You get that now? So my R will be sine, just changing the 60 here. So I have sine 50 divide by 1.50 because it's a constant now. Divide 1.50. That's 0.51. Then I do shift sine is 0.51. So shift sine, the answer we got. The answer. That's giving us 30. So this one, our R, is 30 point, let's say 7 degree. Just something like it. You get that now? That's for what? That's, you can see how easier it is. That's I now. Then when my I is 40 degree, don't forget when it is 40 degree to be sine 40 divide 1.50, then the second function. So we have sine 40 divide 1.50, then the shift sine, the answer is giving me 25 So my R is 25.4 degree. Do you see that now? Very easy. All this story that is here, this is what they are saying. Just look how they are going to do the practical now. So when I is what? Is 30 degree. What do? We say sine 30 divide 1.50, the shift sign, then the answer. So that's that. So we have sine 30 divide 1.50, shift sign, the answer we got. That's 19. R is 19.5 degree. That's our R. Then which one now? You can see. You know they're supposed to be using the rectangular prism to be doing all this, but just watch. So we now have I to be 20 degree. Then what is our R? It becomes sine 20 divide 1.50. Sine 20 divide 1.50. Then shift, sine 20 divide 1.50. Okay, then we have shift sine the answer, and that gives us 13.2. Now look at this. Now, just understanding, this is not what we are looking for. Don't forget, you are not writing this in your booklet. I'm just showing this on the board so that we understand. Now look at what I want to do now, because I still want to follow all this their process, but I have a shortcut so that I don't continue to be looking at the pin that is not lost. You know the way you used to look at it. Some of your tears will be coming out because of rectangular. We have seen a lot of students find this very, very difficult. But just understand, that's the why you need to understand physics principle. That's just what he's saying. For every practical, it came from a physics principle. So this is from Snell's law, and it's fine. So even if they ask me to look for this, I know what to do. If they ask me to look for this angle, I know what to do. Even if it is the lateral shift they ask me to look for, I still know what to do. So just understand the practical. Now let's go. You know, I'm supposed to make use of. I'm supposed to use this. I'm supposed to use. I have my optical pins. I have my thumb pins. You get that now. I have my this. I'm not using any one. I'm not going to use any of this. What I need is just this two. So don't be surprised. This is just what I need. Now what do? I'll just pick, since this is a rectangle, right? This is a rectangle. I'll just pick a length. I'll pick a breadth. So I can pick 12, pick 6. Nobody is going to be mentioning that because you're still going to place this. The normal thing is you're supposed to place this on this and draw. So I can just pick anyone. So I don't need this. So what I need is this. So now look at what we are going to do now. Then I can come and pick 12. Because you need to show this in exam. Why? Because you're going to submit these traces. That's why a lot of students are afraid. Because they know they are going to submit this drawing paper. So they don't want to make mistakes. It's the easiest, if you understand. Especially when it is practical like this, is the easiest. So let's start. So I'm picking 12. Or let me pick 10 so that it will not be 2. I don't want it to be. So let me pick 10. So this is 10 from here to here. That is 10. Can you see that now? Let me pick. I picked 10 already. Then I can pick 5. You get that? Because it's a rectangle. So I can pick 5. You get that now? So what do? I can join these two together now. Then I'll join these two together too. Then I can join this together. Right? Then I can join this together. Don't forget you are submitting our traces. And I can join this together. So we have started. Okay, so what do we need to do? Don't forget that the axons, read along. We said trace the outline ABCD of the rectangular glass prism on the drawing paper and remove the rectangular glass prism. So the main aim of this is for you to place this. We don't need this. Make a position N very close to it. So they didn't give us any length. And where is A to N? That's our normal. So I want to decide to say, let me pick 2. For all the practical, I will pick 2. So let me mark out 2 from here. Let me mark out 2. You get that now? So let me mark out 2 and use 2 as my normal. Use 2 as my normal. But look at the normal. You will see it got down. Do you get that now? It got down. So we are just replicating what they have done. So or down. You get that now? Then the next thing that they did is that they said their eye, their first eye, don't forget, their eye was 60 degrees. I have done all this on my channel. What did I do? How to measure with your protractor. You have been doing that, so you need to understand that. So 60. 60 to what? To the normal. So I place, right? You can see, this is 90. So I'm going to 60, right? So that's 10, 20, 30, 40, right? Look at that. 10, Abby. 20, 30, 40, 50, 60. So 60 is here. Right? So this 60. We are still doing everything they are telling you to do. So what happened? We join it to this place. Make sure it is. So we draw. I don't know if somebody is following me. You see, I've not placed any pin. I didn't use any pin. I didn't use any rectangular glass prism. I didn't use any one. So from there, P1 and P2, right? They said we have P1 and P2, then we have T. Label accordingly, please. So this is T. So I will just put, I can decide to say, okay, this is my first pin. That's my P1. This is my second pin, because it has to be spacious. That's my P2. Don't forget their arrow. You can see the direction of the ray. So you have to put it, very important. So I'll put it. I'll put it. So this is T. Can you see now? Then what is the next thing that we need to do? Now look at this. Don't forget, this is our M, as indicated on the board. This is our R. Do you get that? Now, let's now go back to this. Please bring the camera now. So I'm interested in this now. I want to use this refraction to bring down this and this, because that's what they're interested in. So I want to measure, because they didn't tell me to measure R. If they have told me to measure R, I will still measure. First, a person will say measure R, it's even easier. So from there, our R is 35.2. So let's go now. So I want to use my protractor. I will come and turn this now. Please pay attention to this now. Did you see? So between this line and the line I want to draw now is 35.2, right? So 35.2, I want to count out 35.2 now. So this is 10, right? This is 20, this is 30, this is 35. Don't forget that you use 35, 36 like that. That's also, instead of me taking 35.2, I can just take 35. You get? So this is 10, 20, 30, 35. This is 35. Is that not? This is 35. So I've marked. Why? From the arrow I got, I got 35.2, but I'm using 35. So from here, I'll place this. Let it meet with this line. Very important. You can see this is my 35. So meet with this. Draw it down. Did you see? These are what you are supposed to be doing. Then I'll turn again. I'll turn again. So after turning, you can see that after this is where I am now. Then there is a deviation. So I'll just come. Let me draw this very well. So there is a deviation to this side. So I can just bend my ruler a bit. Do you see that? Because I'm interested in this. So this one is just to fulfill all righteousness. So I'll just bend my ruler a bit like this and draw out. I'm done with the first practical. Let's label now. Let's label. I'll label this, this. I'll label this and I will say this is my P3. Very important. I'll label this. I'll say this is my P4. Did you see that now? Let's see other labeling. Very important. I'll say this is my A. This is my B. This is my D. Let's label accordingly. This is my C. I don't know if somebody is here. Now, what again? This is our R. This is our R, right? Then this is our X, right? Then the middle is our what? Q. Is that not? Then this is our N. This is our I. What again do we need to label? That's all. You are done with the first one. So you can say I didn't even use the rectangular prism at all. I already know I used 10 and 5, right? I used 10, 5. So that's what I want to be doing. So from there, I can now say I from this one, they gave us I already to be 60 degrees. They said we should measure. Now let's go now. They said we should measure. Look at this now. They said we should measure. They appear in a straight line. Draw a line and this join NX. Then measure and record NX as L. So I will measure NX. Do you get that? Then I'll measure RX. So now look at it. I want to measure NX now. NX. So this N, this X, I'm measuring with my ruler. The normal measurement, you should know that by now. So we are placing 0 here. Then we measure. Do you see that now? So this is around 6.4. You see? I hope you are seeing that now. 6.4. So our NX is around 6.40 centimeter. You get that now? While our RX, this is around 3.5. You can see 0, 3.5. So our RX is what? 3.50. This, did I use this? Did I use all this? No. So it's because I understand the principle. So that is the practical. Then evaluate sine Y. Sine I. Sine I is our angle of what? Incident, which is this. Then they said Y, then we should evaluate Y, which is Q over N. So where is our Q? Our RX is our Q. Do you get that? So this RS is your Q. Let me put it in bracket here so that you understand. This is Q. Our NX is our N. That's the first reading got it. That's it. That's how to do the practical. You know, I've saved you from this. You know, be checking. Some people you check. You are not seeing anything. You have checked and checked. You are not seeing anything. You have checked. So this is the best way. So I don't need this. Actually, I don't need this. This is what I need. So I've done the first one. So let's quickly go over the second, third. I'll just do it on 2 or 3. Then that's why you should be able to do this yourself. So the camera will help you zoom it, right? It's even one of the exam questions. So they can zoom it so that you write it. While I am just drawing all this, you can be writing it. So that in school yourself, you can perform it and see if you will get the same thing that I'm doing. So the camera will just zoom to the board while I'm just drawing this very quickly. So that if you want to write the question, you can just write it. So let me quickly draw the second one. Why? If you want to write the question, you can write it. So and that's the reason why I said these things are the secrets you need to know. You need to know it. Yes, you need to just know it. There are secrets you need to know. There are secrets you need to know. Secrets you need to know. So very important. These things are not difficult. You just need to understand the principles. There are every principle that guides. So immediately I want to measure the angle, then I will bring the camera so that you can just do the writing. I'm doing that so that you can do the writing. Don't forget the dimensions. The dimension we took 10, 5. Then from this place now, we did 2. We did 2. We did 2. You can see how easy it is. So we did 2. So draw it down. Draw it down, right? So what's the next thing we do? We measure our angle of incident, and that's what 50. So let's go now. You place it here. Let me turn it. So this 90, so this 10, 10, 20, 30, 40, 50. So this 50 here, right here. So what do? We join this. That's why I love doing these things practically, so that you see it. If you need to check how refraction work is on the channel, you can still. Did you see that now? So don't forget that this is our T. Please don't forget to label accordingly. This is our P1, right? This is our P2. The ray is like this, okay? And this is our angle of incident. And don't forget now, for our, look at that, for our 50 now, we said our R is 30.7, right? For our 50, look at that, our R is 30.7. So I can just do a 31, you get 30.7 approximately. So I can measure my refraction to be 31. So I'll just come here, and this is my 90. This is my 90. Right? I want to believe you are seeing this. Very important. I'm not going to do one, just do 3. Then try to yourself and let's see the answer in the comment box section if you actually got the technique. So this is 10, this is 20, this is 30, right? So we are doing 31. So that means to be here. You get that now, 31. So from there, this is what I'm joining. This and this is what I'm joining. So make sure it is straight. Then I will join. Very, very easy. I will join. So after joining, what do I do again? I'll just bend my ruler a bit to give it that curve that they want us to do. Get that now? So let me increase it a bit because I'll be labeling. You get that? So don't forget the direction of the ray. That means coming like this. So we have our P3, we have our P4, right? We have our R here, we have our X, we have our Q. You get that? We have our N. Please label accordingly. We have our A, there are marks for this B. We have our C, we have our D, right? What again do we need to label? We have our N already. What again? Our R. I think that's all. Yeah, that's all. So you can see. So what do we need to do again now? We need to, our I already for this one is 50, right? Degree. Then our NX, let's measure now. Our NX, this is our N and our X. This is 6. You can see that now. Our NX, this is 6. So our NX is 6.00 centimeter, right? Our RX is our RX. Our RX here, can you see? That's 3. So our RX is what? Is 3.00 centimeter. Do you see that now? That's simple. Let's do the last one now. You can try the remaining 2 yourself. So you can drop the answer in the comment box section for the 4th one and the 5th one. What is the RX? You can try this in your school too. This is very easy. This is one of the easiest, apparatus in physics you can get. You can always get a rectangular glass prism. So that's not a problem. So let's do the 3rd one. And you can see how it is. So I'll just do 1, 2, 3 because we're supposed to do 5. So we'll do 1, 2, 3, 4, and 5. Then you are submitting this thing. You can see how neat it is, even without using this. So let's do the last one. Don't forget our dimension. We did 10 by 5. The 10. Also put your question in the comment box section. Oh, this is bent. Sorry. It's bent. Let me straighten it. So let it be straight. This is 10 by 5, right? So by 5, this is the 3rd one, right? So we're going to stop for the 3rd one. So then you can now tabulate your readings in your booklet. It's an exam question. It's an exam question. I just feel okay. So and don't forget, after that, what did we do? We measured 2 from this place. We measured 2 centimeters from this place. So this is 2 from this place. So what do we do from there? Roll down. You can see. So what is the height that we are measuring? What is the height that we are measuring? 40 degrees, right? So we measure our 40 degrees, which is our angle of incident. 40 degrees, 10, 20, 30, 40. So these are 40 degrees. You can see stress-free. Just understand these principles. 40 degrees. Students waste a whole lot of time on this practical, looking for the optical pin that you are not even seeing. After the end of the day, you still see them. They are not doing what they ought to do. So and when it was 40 from our calculation, we had 25.4. So we are 25.4. So let's measure our refraction. 25.4. So we can approximate 2 to 25 because we will not have that on. Let me turn this. Let's bring it very close. So 90. So this 10, 20, So 25, we cannot have 25.4, so approximately, let's just do 25. So this will be 10, 20, this will be 25. So from there, where's my ruler? Okay, so from there, from this place to the point, which is the angle that we carved out, we draw down. Then from there, I turn my drawing paper, and I can give it the curve that required. Let me increase it a bit. So from there, we have that now. So we can now do our labeling. Please don't forget the labeling carries mark, very important. So because we need to replicate, this is D, this is C, right? This is R, this is X, this is Q, this is N, this is I. The direction of the ray is like this. So let's say this is our P1. Let's say this is our P2. Then the direction of the ray is like this. So we can say this is our P3 and this is our P4. What again? Are we okay? So I think that's all right. Okay. So let's measure our angles. Don't forget that our I here is 40 degrees. Our NX, so this millimeter, turn my ruler. So this is 5.5. You can see here. So our NX is 5.50 centimeter, right? Our RX, you can see 0, that's 2.5. Our RX is 2.5. So try the third and the fourth and the fifth yourself. So let me show you how the table is going to look like now. So the table will be like this, so that when you do your own other two, you can now fill it in the table. So the table is going to look like this. Serial number 1, 2, 3 is our angle of incidence, that is in degree, right? So we started from 60. Let's do to 1 decimal, 60.0. Then we have 50.0, we have 40.0, we have 30.0, we have 20.0. Do you get that now? That's our I. So from our I, what's the next thing that we did? From our I, we got our NX, and don't forget that our NX is what is L. So I can just do L instead of NX. So you can write NX if you want, but let it be L. So this will be L, and don't forget is length. So it will be in centimeter. You get that now? It will be in centimeter. So what was our NX for 60? It was 6.40. For 50, it was 6.00. For 40, it was 5.50. So you can try, I said, try the fourth and the fifth yourself. Okay, but these are your table is going to look like. So it's easier, man. It's easier. So from here, what do we have? We now have that our LX. So after our L now, they ask us to record for our Q2. So that's in centimeter also. So for 6.4, our Q was 3.50. For 50, our Q is 3.00. For 40, it was what? 2.50. So 2.50. Did you see how simple this is? So the next time we should evaluate sine I and Y. So here now, I can now have sine I. So sine I will be gotten with our calculator. There's my calculator, okay? Let's bring it here. So sine I will be from our calculator, and that will be the sine of 60. Sine of 60. That's 0.8. Let me go to at least 2. So let me use this one as, because it's calculator. Let me use 3 for here, for this place, because it's calculator. So 0.866. Let me use this. Then sine 50, 0.766. Then sine 40 is 0.643 approximately. You get that? So when you do your 30 and your 20, you fill your boxes too. So then they said we should now do forward, after and y. But look at the board, please. Let them see this. For our y, don't forget that our y is q over l. So what if it is q over l, our y will not be having units. Did you see that now? Our y will not be having units because they said and evaluate y equal to q over l. So q, don't forget, q is a centimeter, l is a centimeter. So that means we know how units. So we can now say our y will be unitless. Our y, which is q over l. So what's the meaning of q over l from our calculator? Where's our q? This is our q over l. So that would be 3.50 divide 6.40. 0.547 approximately, because we are taking to 3. 0.547. Then we have 3 divide 6 q over l. That's 0.5, so we have 0.500. Then we have 2.50 divide 5.50. Then we have 0.4 approximately 55. That's all. So that's it. So I look at the board now. They now ask us. They ask us to plot a graph of sine I. So this will be sine I. Animation there. Evaluate and record sine I and what and y. So plot a graph of y on the vertical. That's this. And sine I. And add this and sine I. You can see sine I. And that's the practical. So that's the reason why he told us that we need to understand this principle. That's how. So you can try this in your school. Of course, you don't even need what? You don't need a rectangular prism. If you are the serious student, you're supposed to do it yourself so that you see how simple this thing is. And you need to still practice them. Yeah, you need to practice them. So what you just need is just your protractor. Just look for a sheet of paper or your drawing paper. You can try it on your own. Put the answer in the comment box section because I gave you for 30 and 20, right? I gave you for 30 and 20. So what are the values of your sine I and y for 30? And what are the values of your sine I and y for what? For 20. And that is that. So I love you guys. This is Chemistry Hangout. This is one of the best channels as far as science content is concerned. So you don't need to miss any of our uploads. They are wonderful. If you are just joining this very particular channel, kindly subscribe to this channel and turn on the notification bell so that you would be notified when we drop any video. Share this video, comment, like the video. We love you so much. Till we are going to be coming again, we are going to be giving you a lot of principles and we are going to be showing you like this how to solve it. So I have saved you one stress of trying to look for optical pins. Don't look for optical pins again. You can always do the practical like this. Enjoyable, excited, awesome and wonderful practical. So I love you guys. Thank you so much. God bless you. Thank you.